Hello friends, once again welcome back to my channel. Here we are going to discuss about the working principle of three-phase induction motors. Okay, before understanding about the working principle of a three-phase induction motor, it is very necessary to know the constructional details of three-phase induction motor. So that we have discussed about the construction of three-phase induction motor in detail in the previous video. So that first you can discuss about that construction, then only you can watch the working principle of three-phase induction motor. Okay, so for the construction of three-phase induction motor, essentially there must be two parts, stator and rotor. Stator means that includes the stator frame, stator core and stator field windings. Okay, stator core carries or consist with stator windings or simply field windings, and we are providing three-phase supply to the stator winding, and rotor is the rotating parts of the motor and which is placed inside the stator winding. Based on the construction of rotor, it can be two types: squirrel cage type induction motor and slip spring type or face wound or wound type induction motors. Okay, here you can see squirrel cage type induction motor, because in squirrel cage type induction motor, the rotor conductors are slightly skewed and the end regions of the rotor conductors are short circuited by the end rings. Always the rotor of the three-phase induction motors are permanently short circuited. Okay, you can remember that point. So based on that things, we can think about the working principle of three-phase induction motors. Okay, here the principle of operation of a three-phase induction motor is mainly based on the production of rotating magnetic field. Okay, so when we give three-phase supply to the stator winding or simply to the field winding, then what will happen? A rotating magnetic field will produce in the stator field winding. Okay, you can see here the stator winding here. When the three-phase supply is given to this stator winding, then a rotating magnetic field will creates in the stator field. Here you can see magnetic field is rotating. Okay, inside this stator winding, and this is the basic concept. So now let us discuss about the frequency of the rotating magnetic field. The frequency of the rotating magnetic field will be same as that of the supply frequency, because the rotating magnetic field or RMF is produced due to the supply which is given to the stator magnetic field. Okay, so what will be the thing about its speed? So the speed of the speed of rotating magnetic field is known as synchronous speed. So synchronous speed is nothing but the speed of the rotating magnetic field which is produced by the stator field. Okay, so or the stator windings. So this synchronous speed is mainly depends on the frequency and the number of poles. Based on that, here will be an equation for synchronous speed. Ns is equal to 120 F by P. Here F is nothing but the supply frequency and P is the number of poles. So that from this equation it is very clear that the synchronous speed is directly proportional with the supply frequency and which is inversely proportional to the number of poles. For larger number of poles, the speed will be less. For lesser number of poles, the speed will be very more. Okay, so this is the conditions about the synchronous speed. Okay, so we know that the rotor is placed inside the stator. That means when we give three-phase supply to the stator winding, then obviously rotating magnetic field will create in the stator field windings. Means they are rotating with a synchronous speed. And we know that this is the rotor. A rotor is placed inside the stator. That means it is clear that here a relative motion occurs between the magnetic field and the conductor. Why? Because of the rotation of this magnetic field. That means due to the rotation of this magnetic field inside this conductor, what will happen? According to Faraday's law, an EMF will induce in that conductor, right? Because the relative motion is occurred here between the magnetic field and the conductor, so that an EMF will induce in this conductor. So when the EMF induced in the rotor conductor, then what will happen? Since the rotor conductors are permanently short circuited, some current will flow through the conductor. Obviously it is very clear that some current will flow through the conductor. Here you can see the rotating magnetic field. Then what will happen? Motor action will take place here, we can say. What is the motor action? That is nothing but when a current carrying conductor is placed inside a magnetic field, then a force will experience in that conductor. Then definitely, clearly, due to the development of mechanical force, the rotor conductor will rotate. Okay, is it clear? This is the working principle of three-phase induction motor. So once again I will repeat. When we give three-phase supply to the stator winding, then a rotating magnetic field will create. The frequency of the rotating magnetic field will be same as that of the supply frequency, and the speed will be synchronous speed. So due to the rotation of this magnetic field, the flux linkage will occurs between the conductor, means between the rotor conductor and the rotating magnetic field. Due to this flux linkage, what will happen? An EMF will induce in that rotor conductor, or simply if there is a relative motion between the magnetic field and conductor occurs, then an EMF will induce in that conductor according to Faraday's law. So we know that the rotor circuits or the rotor conductors are permanently short circuited. Due to this will create a closed path that will lead to the production of current in that conductor. At that time, motor action will take place. That is, whenever a current carrying conductor is placed in a magnetic field, then it will experience a force in that conductor. Due to that production of mechanical force, the rotor will rotate. And remember that the speed of the rotor conductors will be slightly less than the synchronous speed. That is normally NR. NR is nothing but the rotor speed, which is equal to ns into 1 minus s. Here is nothing but the slip. Slip means it is the relative speed between the rotating magnetic flux and the rotor. Okay, that is normally slip. Slip can be found out by using the relation S is equal to ns minus nr by ns. From here we will get the rotor speed nr is equal to ns into 1 minus s. Okay, and remember that the frequency of the rotor speed will be fr is equal to s into fs. Okay, this is the working principle of three-phase induction motor. In the coming videos we will discuss the concept of slip in detail. Okay, thank you and hope you like the video. Okay.